Students of M.Sc Chemistry from semester 1 of Physical Chemistry and respected listener, a very good afternoon and welcome all of you to today's lecture. Students of M.Sc Chemistry from semester 1 of Physical Chemistry, today I am going to present today's lecture. The title I have mentioned on the blackboard: Weakness, Failures, Drawback, Limitations of Collision Theory and Need of Modified Collision Theory. Once again, I repeat the topic I am going to deliver today's lecture, to present today's lecture. The title I have mentioned on the blackboard: Weakness, Limitations, Drawback, Failures of Collision Theory and Need of Modified Collision Theory. Student of M.Sc Chemistry of semester 1 from Physical Chemistry, today's lecture basically selected from M.Sc Chemistry from semester 1 of Physical Chemistry paper 3, chosen from that is of unit 3rd, titled as Chemical Dynamics. First of all, I bring to draw your kind immediate notice to proceed today's drawbacks of collision theory and modified collision theory. Once again, I repeat, I want to go back of our last video of chemical dynamics to define the derivation of collision theory. Students of M.Sc Chemistry from semester 1, it is very simple fundamental theory to define, to calculate the value of collision theory. We in various competitive examination or various examination conducted at the level of PG, M.Sc Chemistry for physical level, various questions, numerical set. So students become in confused positions. Why and how should the necessarily fundamental equations must be mentioned to derive in collision theory? They are in not such a position to write down the complete notes, necessarily fundamental equations which are required to derive in collision theory. So students of M.Sc Chemistry from semester 1 is very simple. For the descriptions of collision theory, for the derivation of collision theory, students have to derive only the velocity of directions by using two important method. The velocity of the direction one can calculate by using that is of collision theory. Second one, we have to calculate the value of velocity of the direction by using simple chemical kinetics, simple chemical dynamic method. First of all, I would like to calculate the value of velocity of the direction using that is of collision theory. Some important postulates, points listed in our previous last video, chemical dynamics. Once again I repeat, collision theory is basically developed by R.N.S. and Vantoff, the famous popular scientist. The next postulate which is involved to define collision theory, it has been assumed the calculation of velocity of direction in that is of collision theory based upon two important cases. First one, when we are using the different concentration reactant to possess the concentration N and B in terms of dense concentration of the reacting or colliding molecules A and B to produce C and D. Next one, it has been assumed for the calculation of velocity of the reactions, the nature, the behavior and the treatment of colliding molecule must occupy to behave, to act as that is a rigid, dynamic, hard sphere models. I mean to say the calculation of velocity of the reaction is totally purely based upon rigid, hard, dynamic pattern model based on kinetic theory of the gases. Next one, the velocity of the reaction one can calculate by involving two important factors. first one factor which is known as that is of collision coefficient or collision factors, which is symbolized by that is of ZAB, the number of effective collisions which is present, number of intensity for present in that is a chemical vessels per centimeter cube per second of that is of activated complex or active molecules, which is symbolized by that is of ZAB. When ZAB is now calculated, is now multiplied with next important factors, which is known as that is of RNS equation, and that is expressed in terms of e to the power minus E upon RT. I mean to say, according to that is a collision theory, effective velocity of the reaction will be taken into account when excess or much more part of the activated molecules will possess is higher to give the value of velocity of the reaction. When we multiply the collision factor or collision coefficient ZAB, when is now multiply the mathematical value of activated surface of e to the power minus E upon RT to give the value of velocity of the reactions here. Now we calculate the value of, we observe the value of velocity of the reaction by using that is of law of mass action developed by Goodwork on Vargas law. When we compare both of the velocity of the reaction calculated by collision theory, second one calculated by that is of law of mass action, we compare with each other. After the cancellation of Na and Nb, finally equation number 12 is now developed here. Equation number 12 is known as the first types of the incredible equations to define, to calculate the value of that constant, and is also known as RNS equations. Now when we apply, we take the next condition in which all the colliding molecules, reacting molecules to possess the nature of the same molecules to take the same concentration and now expressed in terms of Na in dense concentration. Now again in our last case of case 1, ZAB is now replaced by that is of the same molecule ZAA, which is measured the number of effective collisions per centimeter cube in per second, when is now multiplied the activated activated surface space, which is mathematically measured by in terms of e to the power minus E upon RT. Next one, equation number 16a, 16b and 16c. And after applying the necessarily conditions regarding to that is of velocity of the reaction, K2 is now replaced by that is a K. We need next one incredible reaction is known as that is of fundamental equation. Another one equation is also known as the various forms of RNS equations. So on the behalf of equation number 12 and equation number that is of 16a, 16b and that is of 16c. These were the two important fundamental equations. These equations are the various forms of RNS equation, and one can calculate the value of velocity of the reactions. Now, although collision theory basically gives us necessarily much more fundamental awareness information to explain the progress of the chemical reactions, but I will teach you today some drawbacks, limitations, weakness also existing to define the progress of the reaction, to define velocity of the reactions here. One by one, the drawbacks and weakness and failure. I would like to define is the points mentioned on the blackboard here. First one drawback, according to collision theory, the whole derivation of the equation and expression based on that is of kinetic molecular theory of the ideal gases, where this idea has been introduced, has been involved for the derivation of various fundamental equations by using the important molecular fundamental kinetic theory of the gases. It didn't give us the rest, its depth explanation information regarding to define to other states of the matter, like as solids, like as that is of liquids. Why particularly the kinetic theory of the gases have been introduced to define for the derivation of velocity of the reaction. Next one, the drawback for the derivation of the equation, it has been assumed the collisions of the molecules, the behavior and the nature of the reacting colliding molecules to act just like rigid dynamic hard sphere. I mean to say, the calculations of velocity of the reaction or rate constant based on that is of collision theory, based on that is of rigid hard dynamic pattern. This is basically the pattern where it has been stated here. It doesn't explain. Next one, the drawback, that is collision theory basically explain the kinetics for simple bimolecular gaseous reactions such as the treatment of hydrogen, iodine, nitrogen and oxygen. For such reaction, when we calculate the value of K theoretical and K practical to give the same value. But on the other hand, such typical reactions such as polymerizations of ethylene, polymerizations of 1,3-butadiene and the treatment of bulk concentration of ethyl alcohol along with acetic anhydride, for such typical reaction when we calculate the value of theoretically, mathematically, along with that is of practically, the deviation must be taken into account. I mean to say, K theoretical will not be equal to that is of practicals. Hence, for typical molecules and progress of the reactions, this collision theory doesn't explain. Next one, the weakness and drawback of collision theory I would like to explain among the students. The progress of the reactions, collision theory explain the kinetics of such bimolecular species to possess a single degree of freedom, either to possess to have rotational degree of freedom, vibrational degree of freedom, or that is of translational degree of freedom. But such typical molecules, that is 1,3-butadiene, the intermediate species which is formed between ethyl alcohol and acetic anhydride, such reacting species, such dense chemical reactions in which bulk molecule is produced in the form of intermediate compounds to possess, get together simultaneously three types of the degree of freedoms: translational, rotational, as well as that is of vibrational. I mean to see for 3D types of the typical molecules and its geometry and its kinetic dynamic behavior of collision theory doesn't explain. Next one, according to the collision theory, all the molecules reacting with each other to lead the chemical changes to occur. Once again, I repeat, it is very, very outstanding drawback of collision theory when we allow to react to the various species colliding molecules. According to collision theory, it has been stated, it has been explained, when we heat, we provide the temperature of such reacting species, automatically chemical phenomena will start. So I mean to say, all the chemical phenomena are the responsible. While it is the true fact, only energy of activation will provide to us the necessarily chemical changes here. So, students of M.Sc chemistry, you know, in this in chain reactions, next one drawback, the chain reaction and its rate. We have calculated for fast reactions, excess rate and higher jump of rate is now observed, is now deviated from that is of equation number 14, which is the standard equation of collision theory. I mean to say, for chain reaction, the velocity of the reaction one can calculate much more faster. H2Br to H2Cl2 is comparatively to be measured the velocity of the reaction from fundamental equation number 14. So in order to remove these drawbacks, we need that is a modified collision theory by the introduction of to involve to submit that is of a newly constant newly coefficient is known as that is of P. P is known as that is of probability factor, steric factor, and the modified, finally the modified forms of collision theory is now known as from equation number 17, K is equals to P Z e to the power minus E upon RT, where P is known as probability factor, sometimes it is also known as steric factor, to define the activation of entropy of some typical molecules to define the geometry. Hence equation number 17 is known as that is of a modified collision theory, and that is of next one, its detail that is of explanations theory based on that is of modified collision theory. I will teach you in that is of tomorrow's lecture. Now allow me to join to you that is of tomorrow's lecture. Now you take care yourself. Goodbye. Thank you very much.